Our project will cover basic probability. Our project group includes Alyssa,
Marina,
Dennis,
and Ryan.
Probability rules. For any event A, 0 is less than or equal to the probability of A, which is less than or equal to 1. If S is the sample space in a probability model, the probability of S is equal to 1. In the case of equally likely outcomes, the probability of A equals the number of outcomes corresponding to event A over the total number of outcomes in the sample space. The complement rule is the probability of AC equals 1 minus the probability of A. The addition rule for mutually exclusive events is the probability of A or B equals the probability of A plus the probability of B. Independent events. Two events A and B are independent if the occurrence of one event does not change the probability that the other event will happen. In other words, events A and B are independent if the probability of A given B equals the probability of A and the probability of B given A equals the probability of B. Multiplication rule for independent events. If A and B are independent events, then the probability that A and B both occur is the probability of A intersection B equals the probability of A minus the probability of B.
Independent events. Two events A and B are independent if the occurrence of one event does not change the probability that the other event will happen. In other words, events A and B are independent if the probability of A given B equals the probability of A, and the probability of B given A is equal to the probability of B. Multiplication rule for independent events. If A and B are independent events, then the probability that A and B both occur is the probability of A and B equals probability of A times the probability of B.
Practice FRQ number 1. If we select a student from the school at random, what is the probability that the student is, part A, female? We do the total amount of females, which is 275, divided by the total population, which is 595, which equals 0.462. Part B, someone who eats breakfast regularly. We do the total amount of people who eat breakfast regularly, which is 300, divided by the total population, which is 595, which equals 0.504. Part C, a female and eats breakfast regularly. You find the intersection of female and eats breakfast regularly, which is 110, divided by the total population, 595, which equals 0.185. Part D, female or eats breakfast regularly. So you do the proportion of females plus the proportion of people who eat breakfast regularly minus the intersection of females who eat breakfast regularly, which equals 465 out of the total of 595, which equals 0.782.
Practice FRQ number 2. If we want to find the probability that someone is a Democrat given that they're female, we do 13 divided by 17, which equals 0.765. This is because out of the 17 females, 13 of them are Democrats. For part B, we want to find the probability that someone is a female given that they are a Democrat. For this, we do 13 divided by 60, which equals 0.217. This is because of the 60 total Democrats, 13 of them are female.